Hello again. In this video we're going to be talking about finding the domain of a rational function. So first off, what is a rational expression? A rational expression can be written as a quotient of two polynomials. So one polynomial being divided by another polynomial, where the bottom or in the denominator here is not 0. So here are three examples of rational expressions. This is a polynomial divided by another polynomial. So a constant can be called a polynomial. Same thing here. In general, we usually stick with the rational expressions where there's a variable in the denominator, but a constant is also a polynomial. A rational expression is undefined where the denominator is 0. So just like before with regular fractions, we can't divide by 0. So on these first three here, it says to find the domain of each rational function. So to find the domain, we want to figure out what it can't be. So we can't divide by 0, which means this denominator cannot be 0. So first thing we have to do is factor. For the sake of time, I'm not going to go through all the steps of this factoring, but how this breaks down is the same thing as 3x plus 7 and x minus 1. So if you want to review how to factor that, remember this is a trinomial, 3 terms, and we would take a times c to get negative 21, figure out what adds up to positive 4, and then because this front coefficient is not a 1, we would replace the middle term with the factors we found of 21, and then factor by grouping. And you should end up here, 3x plus 7 times x minus 1. So what that means is x cannot be two things. X cannot be 7/3, negative 7/3, right? If we set that equal to 0, if we set 3x plus 7 equal to 0, we would subtract 7 from both sides, get 3x equals negative 7, and divide by 3. So that's where the negative 7/3 comes from. Now x cannot be negative 7/3 because if it was, this first parenthesis would be 0, and 0 times anything would be 0, and then the denominator would be 0, which this can't be. X can also not be 1, because that would make this parenthesis 1, or sorry, would make it 0, and 0 times anything would be 0, and then the denominator would be 0. So we can't have that either. So one way to write that would just be x cannot be negative 7/3, and x cannot be 1. If you're asked to write it in interval notation, it means it can be everything but negative 7/3 and 1. If it helps you draw a number line, so somewhere would be negative 7/3, and then a 0, and then a positive 1. So x cannot be this, so I'm going to use an open dot, and it cannot be positive 1, so an open dot, but x could be everything else. And that's how we're going to write it in interval notation. So starting at negative infinity, going up to negative 7/3, not including 7/3, so I use a parenthesis, union, still not including negative 7/3, going up to positive 1, not including that, union, starting at 1, and then going up to infinity. So it goes again from negative infinity up to negative 7/3, and then we need this piece here, so from negative 7/3 to 1, and then from 1 to infinity. So we have to get all three sections here, union in between, saying that x could be here or there. Alright, looking at this next one, we're going to factor that denominator to figure out what x can't be. So we want something that's going to multiply to negative 10 and add to negative 3. So I'm thinking 5 and 2 would multiply to negative 10. multiply to negative 10, add to negative 3. And I said 5 and 2. And I need the 5 to be negative, so it adds to negative 3 and multiplies to negative 10. So minus 5 and positive 2. Now what that means is that x cannot be what? What would make this first parenthesis here 0? A positive 5. 5 minus 5 would be 0. And x cannot be negative 2. Negative 2 plus 2 would also be 0. So negative 2. This is going to look similar to the one over here. Again, we're going to have 3 sections. If it helps, you can draw a number line. Let's draw one up here. We've got negative 2 further to the left, positive 5. Can't be that, can't be this, but it can be everything else. So in interval notation, this would start at negative infinity, go up to negative 2, not including 2, negative 2. Union, we want the space in the middle, so from negative 2 up to positive 5, not including either one of those endpoints. Union from 5 to infinity. And then that would be the domain in interval notation. On this last example here, it's asking us what would make this denominator 0. Well, there's no variable in the denominator, and 4 itself will never equal 0. So this one has a domain of everything. There's no restriction. I can put anything I want in for x because this denominator will never ever equal 0. 4 will never equal 0. So I can hit everything in my domain. Doesn't matter that the numerator can factor. It's all about the denominator. The denominator cannot be 0 because we cannot divide by 0. So that's the only piece I'm worried about. That's why I only factored the denominators on the other examples. So the way that we find the domain of a rational expression is we factor the denominator, if it is factorable, figure out what would make each factor 0. That's what x cannot be. And then you could write it listing this, what it can't be, or in interval notation.